saying SOS, get me out of here. But we're going to talk about the AOS, okay? Finding the axis of symmetry. Since a parabola is symmetric, so you have to fill in the symmetric part. Points on either leg are equidistant. What is that? Think of equal distance. Same distance from the axis of symmetry. And the hole punch got rid of some of that. It says if you are given 2 points that have the same y value, if you have a highlighter or just underline, okay? If that is the case, then we can find the value of the axis of symmetry using the following formula. So just write this down. X is equal to x1 plus x2. That is in brackets, and we just divide that in half. Okay? Where x is the axis of symmetry, x1 is the x value of first point, x2 is the x value of the second point. You see what I put there in a note there? The axis of symmetry is also the x value of the vertex. Always remember that, right? It relates right back to the vertex. So it's important. So that equation, study sheet. Boxed in things, study sheet. All right. Next. And please always put the arrowheads in there. And we're going to put the x-axis and the y-axis. Sorry, this is the y, and this is the x. Determine the equation of the axis of symmetry using the parabola below. So what I'm going to do here, if you have a ruler, that'd be great. If not, just try it by hand. I'm going to actually graph my axis of symmetry. Graph the axis of symmetry right down the middle, and let's state the vertex here. The coordinates of this vertex would be 2, 3, right? The coordinates of the vertex is 2, 3. Therefore, that line, the axis of symmetry would actually be x is equal to 2. The song I'm thinking of. Anyways, 2, 3, the axis of symmetry is 2. And notice this. If you have a different color, you can do this. I purposely put these 2 points, like this is on the left leg and this is on the right leg. And I don't know if you should be able to tell that the distance from the right to the center is exactly the same as the distance from the left to the center. And then I went a little bit higher on this parabola. And if you were to draw a line right across, you would also have to say that from here to the center, right, is the exact same distance as from the left side to the center. And that is a very cool property about the parabola. If you know the point on the left or on the right to the center, then you should be able to find the point, the distance to the left as well. It's the same. Okay, so if I use these 2 points, they're at the same height. Notice they both have a y value of 5. Do you see that? I know you're falling asleep already, right? But the 5 and the 5, that should be like ding, ding, ding. They're at the same height. So using 0, 5 and 4, 5, if you have both of them at the same y value, you never use the y values actually for your calculation. You will just go, this is your x1 here. And this, the second point, is your x2. It doesn't matter which one you call x1 and which one x2. It doesn't matter at all. Okay? But what we will do here is we say take the x1, take the x2, and then divide your answer by 2. That's how you would do it. Make sure that the top is done in brackets if you want to do it all in one shot. But we know that it's really 4 divided by 2, which is 2. Did we know this already? The answer is yes. We knew that already. No news there. I'm just trying to show you visually that that is the case. What if we used these two fellas here? Negative 211 and 611. You should notice again that both of them are at the exact same height, same y value. So then you can use this trick. Okay? So the axis of symmetry, again, this is x1 and this is x2. I should probably leave a little bit more room. So I'm just going to go a little lower here. x1 plus x2 divided by 2. Okay. This gives you 4 divided by 2, which is 2. Right? So in both cases, the axis of symmetry is in both cases equal to 2. Okay. So you're like, I knew that already, Mr. Dirksen, but I want you to imagine that this graph would not be there. Imagine for a moment that this graph is not there. This is just to show the idea that I'm trying to portray here. Okay? And so this can be done with these 2 points as well. I will leave that for now. Can you hang in there just for one more example? I'm going to skip this example, maybe come back to it tomorrow. I just need you to do one more thing before we leave. I promise I'll try to do it in 2 minutes. We have 5. Now it's 4. Okay, then flip over to the next page. I apologize if I'm going a little bit too fast here. Halfway through that back side here, given this equation, we're not going to describe the direction of the opening and the width. You should be able to know that, to do that by now. But we're going to focus on B here. It says, determine f of 3. What is that? It means that wherever there's an x, we're going to replace that with a 3. So f of 3, look up at the top here. I'm going to go negative 0.02, 3 squared. Right, I put in the, instead of x, I put the 3 in there, and that existing equation up there, plus 12.5 times 3. Okay. And then I want you to do this in steps. If I ask you to do this algebraically, you go negative 0.02 times 3 squared, and that gives you negative 0.18 plus, figure out what this side is, 12.5 times 3 is 37.5. And then you go negative 0.18 plus 37.5, that is 37.32. Don't pack just yet. This is where the punchline. What did you just find? You found a point on the parabola, which is what? What's x equal to? X is equal to 3, and you just found the y value, which is 37.32. I just need you to be okay with me asking you to actually do this algebraically as opposed to typing it all into the calculator in one shot. Okay, so this is your homework. Skip those that if you find some of them are too easy. Focus on the 9 to 11 if you find the first couple easy, okay? And we'll continue with word problems probably starting tomorrow, okay?